Welcome back, class. I'm Mr. Teacher with the SAT Math video guide, and today we're going to start from number 10. So, number 10. In the figure above, what is the value of PT over PS? So, line PT over line PS, which is this entire thing. PT over PS. Now, what are the things we know? There are two triangles in this figure. There's triangle PQT and there's triangle PRS. Now we need to find the similarities between these triangles. So what can we figure out first? Well, they have the same x degree. They shared the x degree in exactly the same spot. So that's one corresponding side. And since they're both x degrees, we know the angle formed by line QT and line RS onto line PS, the angle is exactly the same. So these lines are parallel. Also, both triangles share a common angle P, either whether it's triangle PQT or triangle PRS. So using the angle side theorem, and so we find that there's one corresponding angle, and one corresponding side. So using the angle side theorem, we know that these two triangles, they might not be exactly the same because this side length is 8 and this side length is 10, but they're still similar corresponding angles. Not angles, they're corresponding triangles. So we need to if they're all, each side corresponds to its own corresponding sign. Line QT corresponds to line RS, so line PQ corresponds to line PR. So likewise, line PT is going to correspond to line PS, and that is what we're going to find. But so maybe you're wondering, where are we going to find the values of those? Well, they're all corresponding. So line PT is part of the small triangle, and we know the length of one of the sides of the smaller triangle, which is 8. So we can set it up as PT equals to 8, and then PS, which is the entire triangle, we have the value of the same length, which is 10. So the proportion is going to be 8 over 10, which when you simplify it, simplify by 2, and we get 4 over 5. That is choice E. And I might do a separate video on angles and sides because that's actually very important in the SAT. These questions come up like on almost every single section. So I might do a little mini side video of that. But anyways, number 11, and this is a very complicated graph. Okay. I don't know if I can draw it in time. Uh, hmm. I'll draw it to the best of my abilities, which is not that good. Oh no. This is gonna take up a lot of time on the video. I'm sorry. I should do these earlier. But my studio isn't set up yet. Oh, that looks like a very weird comb. Let's sort of cover this off. 3, 4, 5, 6. Okay. Plus the color is green. It's so horrible. Okay. good. Now we need to label 0. It goes all the way up to 140. 20, 40, 60, 80. Oh. Did I miss a spot? Oh, no, I didn't. I thought I forgot one of the grids. Okay, and this is length in millimeters. And over here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And these are week. And let's do the points on the graph in a different color. Okay, there's one over here. 3, there's another one over here. 5, this seems to be going in a pattern. Yeah, I can see the pattern already. Week 9, it's over here. Week 11, it's over here. Okay, I drew it as fast as I could. So, a biology teacher graphed the length of a fish over time, and the results are shown above. If L represents the length of the fish in millimeters, and W represents the number of the week, which of the following equations best describes the data shown? Okay. So, we just need to find a pattern in this graph. So, if there's one thing that you noticed by now, and I've noticed it while I was drawing it, is this. On week 1, the length, which is L, equals to 10. On week 3, the length is approximately equal to 30. On week 5, again, it's approximately equal to 50. So, length equals to 10 times W, because each time you just multiply it by 10. We could keep on going. On week 7, it's approximately 70. On week 9, it's almost 90. So that's our equation, and that's choice D. So a very complicated graph for me to draw, and it took only a 10 or 20 seconds to solve it. Okay, so let's not think about that. Number 12. And there's another sequence. 5, 6, 5, 6, 7, 5, 5, and 6. For the numbers listed above, the only mode is 5, and the median is 6. Each of the following could be the value of n except. So, if they're asking for a question of medians and modes, what I like to do is put the numbers in order. So let's see, there are 1, 2, 3, 4, 5. So 5, 5, 5, 5, and there's 1, 2, 3 sixes. Oh no, not 6 threes. 3 sixes. 6, 6, and there's 1, 7. Okay, so which of the following cannot be the value of n? So the median has to be 6. Oh, and there's another n, which is going to go somewhere around here, either here. Okay, so the only mode can be 5, and the median has to be 6. So just a quick review, mode is the most common number, median is the middle number, and another one usually comes mean, which is the average, but we're not going to use that in this problem. So this is just a little bit of figuring out. If it says the only mode is 5, then choice A says 6. If we add 6, then there's going to be 4 sixes. But there's also going to be 4 5s, so there's going to be 2 different modes. and that's not gonna work out because the only mode is gonna be 5. Now if you add any other number, it's, well, oh, if you add any other number in the choices, there's 7, there's 8, there's 9, there's 10. Any single number, it could be any number bigger than 7, even if it's 21. I don't know why I picked 21. So the mode is still going to be 5, and when you count, there's a total of 9 numbers. 1, 2, 3, 4, 5. 6 is still going to be the median, but if 6 was over here, like somewhere over here, 6 would still be the median, but it would also be a mode, so that wasn't going to work out. So the only value of n that doesn't work is 6. That's choice A. So, next problem. Number 13, and there's another drawing here. It's a Venn diagram, Mickey Mouse Venn diagram. Okay, that's as good as it gets. X, Y, not really, there's loose ends all over. X, Y, Z, 5, 3, 5, 4, 2, 7, 3. Okay, in the Venn diagram above, the number in each region indicates how many elements are in that region. How many elements are in the intersection of sets Y and Z? Well, what's set Y? It's this one. What's set Z? It's this one. So where's the intersection? Well, the intersection is right here. This entire little overlapping is the intersection between Y and Z. So it's 7 and 3. So that's equal to 10. That's choice C. That's as simple as it gets for a Venn. For number 13 at least. Okay. So number 14, and it might be the final question for today. If m equals to t cubed for any positive integer t, and if w equals to m squared plus m, so what is w equal to in terms of t? So wherever we see an m in this equation, we just put t cubed over there. So w equals to t cubed squared plus t cubed. So w equals to, when you raise a power to a power, you multiply the power. So t, 3 times 2 is 6, t to the 6th plus t to the 3rd. And that is w in terms of t. That's choice E. And thank you guys for watching. I hope this helped you with your SAT preparation for math. And I don't think I missed anything, right? I don't think I missed anything. So I hope to see you in the next video. See you soon.